Welcome to another exercise for the workbook statistics. This time I'm going to talk about an exercise on how to determine confidence intervals for means. Our exercise here: calculate a 95% confidence interval for the mean of the results of an assessment center test based on the following scores. So here, if we take a closer look, we see we have 10 different result scores. And we should calculate the confidence interval for the actual mean. In this case, we're going to start with calculating the arithmetic mean, which we need in either case. For the arithmetic mean, this simply means adding up all values, dividing this by the number of observations. So adding up all of this, 10 observations, so we divide by 10, giving us in the end a result of 97 points. Well, that was the first step. Then we can rethink what we have been given in the exercise, or rather what we haven't been given, and that is any information regarding a variance or a standard deviation. So we have to calculate them here as well, the next step. And well, how do we go about this? The formula for the variance is relatively straightforward. From each of these values, we are going to subtract the average. That's what we've done here. And then we're going to square the end result. We're going to do this for all of the different values we have. So we're doing this 10 times, adding up all of this. And then we're going to divide this by the number of observations minus 1. Here we have 10 observations, so we're dividing this by 9. We could also have selected a different approach for the variance, but well, here we're going with the standard formula. If we put this into a calculator, in the end we get a result of 591.5556. Well, that's the corrected variance or sample variance, but we are interested more in the standard deviation, in a corrected standard deviation. So what we're going to do next is simply take the square root of this value, which then yields us a standard deviation of 24.3219 points. With this, we're only missing one final value. Since here we already said we do not have any information about the variance, and we have the disadvantage of having only 10 observations. Here we're going to use the t-distribution version of the confidence interval. So what we need in the final step is the respective quantile of the t-distribution. Well, what is the respective quantile? It's actually t n minus 1, 1 minus 1 half alpha. N, we said, is 10 observations, so we have 10 minus 1, that's the 9 here. Then we have 1 minus 1 half alpha. Alpha is the error we make, the margin of error. If we have a 95% interval, it means the margin of error is 5%. So here for alpha we're using 5% or 0.05, giving us then a value of 0.975. This might look a bit strange, but well, we have a 95% confidence interval with 2.5% of the errors on the left side and 2.5% of the errors on the right side. That's why we are only here subtracting 2.5% from 100 and not 5%. Well, if we look up this value in the table, we get 2.2622. With this, we have the final value we need for the construction of the interval. So I'm just going to summarize our intermediate results, the 4 values we have: arithmetic mean, corrected standard deviation or sample standard deviation, quantile of the t-distribution, and number of observations. Because if we look at the corresponding formula for the confidence interval, as in that one, we see we require 4 values, and that's the 4 values given up here. So we can simply plug these values into the formula, getting this intermediate step, then calculating both sides with our calculators. This gives us something of 79.6008 and 114.3992. So if we round this, 79.6 and 114.4. So somewhere in between these two values, the real mean of the assessment center results will lie. That's actually a pretty broad interval, but that's due to the small sample size of only 10 observations. So for 10 observations, that's actually a decent result. Well, that's everything there is to the construction of these confidence intervals. So I hope you enjoyed it. I say goodbye and see you next time.